Hi, I'm going to go ahead and show you how to create your vector graphs using the polar format as an input. This is going to be a little bit of work, but you can do it. First, we're going to start by creating our polar format. Now I'm going to create an area called magnitude and angle, so they're right next to each other. And I like working in degrees. I'm not a big person who works in radians, so therefore that's going to be something that we're going to have to change here. When I enter things into degrees here, Excel wants everything's in radians, so therefore we will make that change in our actual formulas. Alright, I've entered in a couple of values here. I'm going to say 5 is a magnitude at an angle of 34 degrees, 14 magnitude at a negative 56 degrees, 24 is a magnitude, and again, it could be voltage, current, resistance or impedance at this point, all sorts of things that you want to work with here, but again, 24 at a magnitude at an angle of 12 degrees. Now what I need to do is I need to convert those degrees into radians. And as you see, I'm going to use this equals radians of C3 right here. Go in here. Has to be in capitals. There we go. And I'm just going to copy this down just to have that easy there so I don't have to worry about each one of those. Just me doing a quick these problems there. So once we've converted these to radians, in my opinion, it's just easier just to go from here. Now I'm going to convert each one of these polar things into our x and y. So again, x is going to be on the real axis. I'm going to call this the real axis. Let me call this imaginary axis. Okay, and this is going to be equal to the magnitude times the cosine of this here. And it doesn't like that. I'm going to put in the brackets. That. And there we go. And the imaginary part is going to be equal to the magnitude times the sine of that same. Right. And it should be B, not 38. Must hit it real quick there. B3 times the sine. So therefore, here we go. And now I can just copy this through. Control C, Control V. All right. So there we go. There's our real and imaginary aspects of it. Okay. So this is our those x and y values. And what I'm going to do now is that I'm going to just make x equal to each one of those. So this is going to be equal to my x-axis here. And this is going to be equal to this x-axis here. And this one is going to be equal to that x-axis here. And again, we're going to be setting this up as a x and y. This y is going to be equal to that very first one. This y is going to be equal to the next one. And our last one is going to be equal to this one here. Awesome. Okay. And what we can do is we can actually add the summations of each one of these two is equal to the sum of the quantity of this. And we can go, oh, don't better not just use sum, is equal to the x plus this x plus this x, right? And the y is going to be equal to this y plus that y plus that y. And that's actually our resultant vector right there, right? That's where it's going to actually end up. So now all I have to do is create insert, again to a chart, go to scatter graph, and I don't like this, because I had that preset. Don't want to do it. You can see why we don't preset those things. Select data. Let's remove these ones here. We're going to add in, again this is vector 1 or v1 I'll call it. X-axis is going to be here. Y-axis, you can delete that and select that one there. There we go. Hit OK. Add another one. We're going to call that V2. Select our value here. X-axis. Come up here to Y-axis. Select our Y-axis now. And again, this is a starting point and ending point on Y, but we have to set up as those points there. Hit OK. Edit this one here, so V3 X, and once again get rid of that there. Select that. There we go. And as you see, now we have our vectors here, and let's add in our resultant value. X-axis is going to be from here, and our Y value is going to be here. And we hit OK. So again, here's V1, V2, V3, and here is our resultant vector if we add them all up together. And as we can see, that would be a pretty nice vector graph right there. And anytime I want to, if I change this and say, oh, well, I need to bring this in, what can I do? If the angle 5 was, it wasn't 5, let's say it was 8. As you can see, the vector will automatically change for us. And as you can see, if we keep on bringing this up a little bit more, if we bring up the magnitude, let's make it 13. Up a little bit too much, let's make it 12. Look at that. The resultant vector is pretty close to 0 with these values right here. Hope this helps you. It might be a little more fun just to be able to put this in here in a polar format and have it change automatically to your rectangular format so you can do the graphs. I find it interesting. It took me a while to figure this out, and hopefully you've are going to gain some use out of it. Thank you much.